This is Utkarsh Grover back with another video. This video is question number 2 of assignment 3, and here we go. So the question number 2 states that x is uniform in between limit a to b, both of a and b included, and y equal to x square. There are two parts of this question. The first part, that is a, find and draw small fx and capital Fx. Question number B, given that a equal to -1 and b equal to 3, find and draw fy and capital Fy. Also find estimated value of y. So here we go. We have x is uniform in between a and b, both included, and y is equal to x square. So find and draw fx and fxy, capital of f of x and capital f of x, small f of x. So as x is between a and b, as x is uniform between a and b, so we get this answer. So that is small f of x is uniform between, so small f of x is equal to 1 upon b minus a when x is between a and b and 0 otherwise. So when considering it is constant between a and b, that is 1 upon b minus a, so this is constant between a and b, and before and b plus is 0 as the graph is on 0, and a before a it's also 0. So this gives us small f of x. In considering capital F of x, so capital F of x, when capital so the value of capital f of x when x is when a is greater than x, so when a is greater than x it's 0, so it's 0. When it's between, when the value of x is equal to a, equal to or greater than a and smaller than b, the value is 1 upon b minus a into x plus 1. So it's 1 upon b minus a into x plus 1. So that will be a straight line towards 1 and this value, and before and after it's greater than equal to b, it's 1. So till b the value is 1 upon b minus a into x plus 1, and after b it becomes equal to 1. So this is our graph of capital F of x, and this is our graph for small f of x. Now the second question is suggests a equal to 1, a equal to -1, I'm sorry for that mistake, and b equal to 3. Find and draw small f of y and capital F of y. Also find the estimation of y, which is here as we can see. So small f of y is equal to 0 for y is smaller than 0 and greater than equal to a, greater than equal to 9. So it lies between 0 and 1. So when the value lies between -1 and 3, the value is equal to 1 by 4, as the value of y is equal to x square. So as the y equal to x square, so for y smaller than equal to 0 and smaller than 0 and greater than 9, so for y is 0 between 0 and 1, y is equal to g of x equal to x square, where x is equal to plus minus root of y. The plus minus root of y gives us this value. So the graph of y equal to x square is a u-shaped curve which goes from which have its point at -1 and 3. As we can see, the points are between -1 and 3. So those are our two graphs. Small f of y is equal to small f of x upon g dash of x. So g dash of x plus small f of x upon g dash of x1 and g dash of x2, that is equal to 1 by 4. That is equal to 1, that is small f of value of small f of x1 is equal to 1 by 4, and the value of small f of x2 is also equal to 1 by 4. The value of g dash of x is equal to minus 2 root y, and the value of g dash of x2 is equal to 2 root y is equal to 1 by 4 root y. For when the value of y is greater than or equal to 1 and smaller than 9, there is only one root. So when there is only one root, we have the formula for small y. Small f of y is equal to f of x upon g dash of x, that is equal to 1 upon 4 divided by mod of 2 root y, that is equal to 1 upon 8 root y. So as we can see, there were two limits we have, when y lies between 0 and 1 and when y lies between 1 and 9. So we have now compiling the results of y lies between 0 and 1 and y lies between 1 and 9. The results are, the small f of y value lies is 1 upon 4 root y when the value of y lies between 0 and 1, and the value of same y when it's between 1 and 9, it's equal to 1 by 8 root y, or 0 otherwise. From this we can calculate the value of capital F of y, as we have calculated the capital F of y here. So the calculation of capital F of y, when y is smaller than equal to 0, the value is 0. When y lies between 0 and 1, 0 included, the value is 1 by 2 root over y. For y, when y is between 1 and 9, 1 included, the value is 1 upon 4 root over y plus 1. And for every y that is greater than equal to a, we have a value of 1. So now we have the value small f of y value and capital F of y value. Now keeping these now we have small f of y value and capital F of y value. So now we can make graphs. So the small f of y is 1 upon 4 root y into u of y minus u of y minus 1 plus 1 upon 8 of y into u of y minus 1 minus u of y minus 9. This is the this is the limit when value of y lies between 0 and 1. So this is 0 and this is 1, and for y lies between 0 and 1, it's 1 upon 4 root y, so it's 1 upon 4 root y. When value of y lies between 1 and 9, so the value is 1 upon 8 root y, so we have 1 upon 8 root y, which gives us the following graph, that when value lies between 0 and 1, it's this, and when value lies between 1 and 9, it's this. Here 0 is included and here 1 is included. So we have the graph for small f of y. Considering the graph of capital F of y, the value of capital F of y is when it's smaller than 0, it's 0, so we don't have to consider it. When it's between 0 and 1, 0 included, we have root over y, 1 upon 2 root over y, that is between 0 and 1, as we can see. For it value that is between 1 and 9, 1 included, we have 1 upon 4 root over y plus 1, which is this, when value is between 1 and 9, and after that it's equal to 1. So the graph will be like a straight line from here onwards. So making a graph that is between, when it's between 0 and 1, the value will be 1 upon 2 root over y, that's this graph. And when it lies between 1 and 9, so the graph will be slightly curved towards 1, and when it reaches value 9, it will be a straight line. Finding the estimated value of y, so we have both the graphs of small f of y and capital F of y from their relative values. Now we have estimated value of y. So estimated value of y is 1 upon 4 0 to infinity y into 1 upon root y dy plus 1 upon 8. So that is 1 upon y, that is 1 by 4, that will be constant, and 1 upon root y, that's from here, plus 1 upon 8, that's from here, one constant, and y into 1 upon root over y, that's from here also, into dy. Solving this equation and keeping the values, substituting the values and substituting the limits also, we get 1 upon 8 plus 1 upon 12 into 27 minus 1, that will be equal to 7 by 3. So this was our second question of homework number 1. Homework number 3. Thank you.